Hello guys, today let's solve this Leetcode hard question, which is pre-image size of factorial zeros function. The question name is a bit hard, but it's actually easy. So now let's see what they're giving us. In the question, they're giving us a integer k, which represent the number of trailing zeros that they want at the end. So they want us to return the number of numbers that have k number of zeros at the trailing position. So to solve this question, you already need to know how to count the number of trailing zeros for a given factorial number. I already made a video on that, you can watch if you want. So I'll be explaining this question thinking that you guys already know how to do that. So before we solve this question, let's understand a few things. So 1 to 4, if you take factorials of 1 factorial or 2 factorial or 3 factorial, we would be getting 0 trailing zeros because there are no factors of 5 inside these. If you go from 5 to 9, you would be getting 1 trailing zeros. If you go from 10 to 14, you would get 2 trailing zeros, and so on. So what do you understand here? If there exists a number that have k number of zeros, then the answer will be 5. But what if there isn't such number that have that many zeros? For test case such as 24, which will be 4 trailing zeros, but for 25, since 25 contribute to 5 as we discussed, so when k is something like 5, the answer would simply be 0. So the answer is just two options, either 0 or 5. That's it. In the question, they didn't give us any type of range. So how do we know? I can't run a loop till infinity, right? I need some set of range to find it. So what to do? The range would be starting from 0, but till how much? That's what we don't know. From my previous explanation, it's clear that every 5 block of numbers contain 1 trailing zero which increment as we move. So to find k number of trailing zeros, we need roughly about 5 into k numbers. So that will be our range. We will go from 0 to 5 into k. But if you look at the solution section of Leetcode, few people would also plus 5 or plus 25 or plus 125, whatever, because I gave the reason of power of 5, skip 1 trailing zeros. Like 24 factorial, you'll get 4 trailing zeros, but 25 factorial, you'll get 6 trailing zeros, right? But honestly, I tried without doing this and it worked for this question. So let us keep it simple. And now that we know the range and we have to find a k, it's pretty simple what to do. Just use binary search. And that's what we are doing. And yeah, that's how you solve this hard question. See you tomorrow.